All right, we're looking at independent practice 5-2. This is number 6. So we got a bag full of marbles. There's 4 blue marbles in there, there's 9 red, and there are 7 yellow. And if I counted right as I drew it out, it looks just like that. So we have 2 probabilities that they want us to compute. We're going to draw 3 both times, and we want to get the probability of getting red, red, and red. So basically 3 reds in a row. Now the key difference here is that once we're going to calculate it when we replace the marbles, and once we're going to calculate it when we don't. And that does make a big difference. This actually is going to give you now independent events, because when you put them back, you're not changing the total at all. But this is going to give you a dependent event, because as you take them out, you are changing, and you keep them out, you're changing the total number of marbles in there, and you're changing the proportion from one color to another. All right, so let's do the first one. These are independent events, and when we have 3 reds that we're drawing, when we want to do red and red and red, because they're independent, we can do the probability of red times the probability of red times the probability of red. We can just calculate the individual probabilities and multiply them out. So this should be fairly straightforward here, because the red, looks like we got 9 of them, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. I did draw it correctly. And then I'm just second guessing my addition skills here, so I got the calculator out. I want to add 4 and 9 and 7. 4 plus 9 plus 7, it's 20. So there's 20 total marbles in there. All right, so I have the options of getting 9 out of 20. There are 9 red marbles out of 20 total. So I pull one out, that's the probability of getting a red. I put it back, I replace it, and I do it again. So once more, it is 9 out of 20, and then a third time, it is 9 out of 20. So I'm going to use the calculator here to get the probability. I need to multiply 9 out of 20 by itself 3 times. So I can actually do exponents. I can do 9 divided by 20, and then I can raise that to the 3rd power. So that's my approximate decimal. By the way, if you don't like doing that, you can do 9 divided by 20 times 9 divided by 20 times 9 divided by 20. You can multiply it out 3 times. It's the same thing. So it looks like that's about 0.09. If we want to make it into a fraction. Oh, that is a big, long fraction. It doesn't look like it's simplifiable. So it's 729 over 8,000. I'll just jot that down. 729 over 8,000. It looks like that decimal was about 0.09. I'm going to go 3 decimal places, 0.091. 0.091. The reason I wanted to do that is that way when I go ahead and make it into a percent, if it's going to multiply by 100, right, I'll show you in the calculator. Let's go back to the decimal. Times 100. It's about 9.1%. So fairly low probability that this is going to happen, that I'm going to get 3 reds in a row. Okay, so now what I want to do is I want to talk about what happens when we don't replace. Now that creates a dependent scenario. So what's going to happen is to do probability of red, 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 is the probability of getting 1 red times the probability of red, given that I already got a red, times, I don't quite have enough room here to slide this guy over, just give myself a little bit more paper, times the probability of red, given I got a red, and then I got a red before that. Okay, so it looks kind of like this. Now the first one is the probability of red. We already know that. It's 9 marbles out of 20, so 9 out of 20. Now here's what happens on this next event. I have taken a red out and it is gone. So I stole some hole punch things from my hole puncher. Now I do not have as many reds. Because I got a red already and I'm not replacing it, I now have only 8 reds left, and I have 1 fewer marble in there too. So I have 19 total marbles. And then if I do that again and I pull a red one more time, oops, I pull out another red, I am left with, again, 2 now fewer reds. There's only 7. Look, 1, 2, 3, 4, 5, 6, 7. 7 total reds, and there are 2 fewer marbles in there. So I have 18. Now this is one I definitely want the calculator on, because I need to multiply those guys out. I'll set it up over here. We can kind of see it there. So let's do 9 divided by 20 times 8 divided by 19 times 7 divided by 18. And I have a feeling this is going to be a really big fraction. Negative fraction. Oh, it's not that. Actually, this is way better. I thought this would be worse. Simplifies better than I thought. 7 out of 95. If I go back to the decimal, around that, right, we'll go math, go back to the decimal. Oh, so let's go 3 decimal places again. 0.074. So that means if I multiply it by 100, it's about 7.4%. All right, so the probability, here I'll slide this up a little bit. Probability of getting 3 reds in a row when I replace, a little bit higher at 9.1%, a little bit lower when I start taking them out. So this is less likely. This guy here is less likely. Which makes sense, we're removing reds from the bag. This one is more likely. We're keeping them all in there. Hope that is helpful, and message me anytime with questions. I'll see you in class.